Welcome to clickmyproject.com. Our product title is Current Mode Clock Synthesis CMCS. Let us see about abstract of our product. In the past, the major issue of the VLSI designer were area, cost, performance and reliability power consideration was mostly of only inferior importance. But over the last few years, power in the circuit is the major problem nowadays, which is being faced by the very large scale integration industries. The power dissipation in any circuit is usually take place by the clocking system, which includes the clock distribution system and sequential elements such as flip-flops and latches in it. The amount of power dissipation by any clock distribution system and sequential circuit in any chip is about of 30% to 60% of the total chip power dissipation by the circuit. Clock is the most important signal present in the chip. Clock signals are synchronizing signals which provide timing reference for computation of any working synchronous digital system. In the proposed implementation is focused on above mentioned drawbacks and also it overcome that. So overcome that in this design, and this is done in Tanner EDA tool 45nm and 20nm CMOS technology. Next we see about flow diagram of our product. In this flow diagram consists clock gating. That clock gating is fed into the interconnect network. In the interconnect network having resistor and capacitor elements, in the interconnect network is fed into the proposed PFF and transmitter circuit. After that, the transmitter circuit is fed into the receiver unit. The overall communication process is processing in this manner. In this flow diagram consists various modules, that is transmitter, D flip-flop, clock gating, interconnect network, receiver unit, voltage generator and register stage. First one, the transmitter is nothing but that is transmit the signal or data from one end to another end. In the transmitter unit is connecting with the antenna, then that excite the alternating current, then the data will be transferred. After next module is a D flip-flop module. D flip-flop module is nothing but that having 4 terminal, 2 input terminal to output terminal, the 2 1 data and clock. The data is input data is given into that terminal, the clock is given into the clock terminal. When the clock is enabled, the data is delivered to the Q output terminal. In Q bar, that output data will be inverted in that value is getting in the Q bar terminal. So the D flip-flop is used mostly because the data is given when the clock is enabled. After that, that is connected in a clock gating. Clock gating is nothing but clock is very important, that high frequency clocking is given into the overall circuit. So that clock gating is fed into the interconnect network. Interconnect network is nothing but that interconnection between the CMOS driver and receiver side. In the interconnection network, resistor and capacitor is used for the filtering purpose, and that interconnect network is fed into the transmitter side. In the transmitter side, two various blocks are used. One is the D flip-flop, another one is voltage generator. In voltage generator is nothing but that is a reference voltage generate in that block. That value is compared with the value getting from the interconnect network. That compare output is fed into the D flip-flop. The output of the transmitter is connected to the receiver side. In the receiver side is nothing but the overall process is the ending side. So the data will be received in the receiver unit, and also the data is feedback into the transmitter side. Next one, the receiver data is fed into the register stage. Register stage is nothing but is used for the storage purpose. All receiving data will be stored in the register stage. Next we see about running process of our product. In this proposed implementation is done in Tanner EDA tool in 20nm and 45nm CMOS technology. First we open the Tanner SEdit tool, then create a new cell view. After creating the new cell view, as per the circuit diagram, we create the element in the manner. After creating that, we give the simulation time and module 45nm module or 20nm module we given into the separate library files. After that, we click the simulating run icon. After clicking that, the output will be displayed in the tSpice window. In the tSpice window, the D data will be shown, and also this is the output data waveform. This is getting from the WEdit tool. These are the overall output waveform. If you want to view in separate, then click the expanded chart, then the data will be changed in the separate view. This is output waveform, and also we able to calculate the power and time. This is the time waveform. This is time value is getting in the tSpice window. So in this tSpice window we can able to calculate the power value. So we give the command in the tSpice window, print trans P and sub which voltage source you given into the calculation. So we given that command in the tSpice window. After that, we click the run icon, then the output will be displayed in the WEdit window. This is the power window. This is power value waveform, and this is the corresponding input output data. The power value is around 250 microwatts. So this is the value range will be given in the waveform. This is the lower value, this is the upper value. So we change the limits, then the difference between the two ranges will be displayed. So 373 microwatts will be getting in the power consumption. So overall power consumption will be reduced in the conventional method, and also overall efficiency will be increased. Thank you for watching this video.